Hi everyone, this is my Falling Spring lab for Physics 2211, Lab 5. Purpose of this was to observe the motion of the slinky as it dropped from a given height, and whether the slinky would drop all in one go, or the bottom would fall first, or the top would fall first, basically which way the spring would fall. And then basic physics principles are Newton's second law, gravitation, the surface of the earth, spring force, net force, energy principles, potential energy, etc. And then systems, mass, spring, and earth. Oh, there is no mass. I like the spring and the earth, and the surroundings is nothing else. Fundamental principles, we have spring force on a system due to a spring. Spring always tends to pull in direction to restore L naught. And this is just, I guess the spring is acting as its own system, and the gravitation is pulling it down. And the gravitational force is a force on the system due to gravity on Earth, always points in a direction towards the center of the Earth. Net force action on the system is these summing together. And not to spoil it, but the bottom of the spring stays still while the top of the spring moves down because spring force and gravitational force cancel out until the top of the spring reaches the bottom of the spring. And so therefore, once that happens, they all move together with gravitational force because there no longer is spring force because L naught was restored. But before then, spring force and gravitational force cancel. So the bottom of the spring stays still. And this is more energy stuff that you can apply, but is not really applied in here. This was the tracker app, and this was a spring falling. You can see this is the graph of the bottom of the spring. You can see it stays completely still. And then the top of the spring moves in a completely linear way, going straight down. Well, it's actually not entirely linear, but whatever. And then this goes like this. Next. This uses Newton's second law to calculate updated positions at each time step. It uses force equations to find total energy of the total force of the system and visualizes the position, and it worked pretty well. It uses the code that was used. This expresses weight and height and all this, and this is the velocity update, which this takes into account the gravitational force. And this is spring force plus gravitational force, and then the position update, which is this, the velocity update times the time, and then time is updated, and then all of this happens as well, and all it's just the graphing. And then this is here we have more of this, and we have the spring force here, and you can see the rest of the code there. And this is the difference between the computational model and the tracker. And this was tracker right here. You can see a similar horizontal line that turns into a linear line. And at this point right here is when the top of the spring hits the bottom of the spring. And then they start moving together down. And that is the end of my presentation. Thank you for watching.